For the past 100 years, there have been people who have dedicated their lives to listening to the cosmos in hopes of catching even a hint of the existence of other civilizations. It all began back in the second quarter of the 20th century, when radio astronomers first wondered, could someone on the other side of the galaxy send us a signal? In 1959, two scientists, Frank Drake and Giuseppe Cocconi, were the first to seriously propose searching for artificial radio signals at the wavelength of 21 centimeters. This is precisely the frequency used by neutral hydrogen, the most abundant element in the universe. Just a year later, Frank Drake began the first scientific experiment in history to search for signals from extraterrestrials, which was called Project Ozma. Using a radio telescope in West Virginia, he listened to the stars closest to Earth, Tau Ceti and Epsilon Eridani. At that time, no signal was detected, but this experience marked the beginning of an entire scientific field, the search for extraterrestrial civilizations through radio waves. Over the following decades, numerous antennas specifically aimed at the sky appeared all around the world. The famous organization SETI, since the mid-1960s, has brought together scientists from different continents. They developed increasingly powerful radio telescopes and computer algorithms for the automatic search for unusual messages from space. Millions of stars were selected for the search, and optical telescopes were also brought into play. What if aliens decided to wink at us with a giant laser? In Northern California alone, in the 2000s, the specialized Allen Telescope Array appeared, consisting of hundreds of antennas, capable of simultaneously listening to thousands of regions of the sky. All this time, signal hunters faced technological difficulties, funding interruptions, and even embarrassing moments when the antennas picked up reflected Earth signals, like microwaves from a nearby university. Despite all the setbacks, enthusiasts did not give up. Powerful computers joined the search. Thousands of volunteers around the world analyzed data on their home computers through the SETI at Home project. By the middle of the 21st century, the database of suspicious signals had grown to hundreds of thousands of entries, but there was still not a single one that clearly indicated extraterrestrial intelligence. But at the very heart of this story lies a truly mysterious case that still sparks debate among astronomers worldwide and continues to draw attention even decades later. In August 1977, something truly strange happened at the Ohio State Observatory. Jerry Eman, a scientist working at the radio telescope poetically named Big Ear, noticed a signal among a mass of routine printouts that was completely unlike the usual galactic noise. An extraordinarily powerful burst was detected at a narrow frequency of 862 MHz. On the computer printout, it appeared as a sequence of numbers and letters. The sequence was so unusual that Eman, unable to believe his eyes, circled it with a red pen and, caught up in the moment, wrote in the margin, "Wow! This is how the most famous and mysterious signal in the entire history of the search for extraterrestrial civilizations got its name." This mysterious signal lasted only 72 seconds and was never detected again. The radio telescope was set up to track celestial objects as they moved across the sky. This meant that no terrestrial source could have matched the timing so perfectly. The intensity of the signal was so high that it was immediately recognized as anomalous. By all indications, this was something extremely unusual for natural cosmic processes. No satellites or airplanes were found in that sector of the sky that could have interfered with the telescope's operation. None of the known radio transmissions on Earth matched the timing, and repeated attempts to catch the signal in the same part of the sky yielded no results. The location of the source was searched for years. It was located somewhere between the constellations Sagittarius and Capricorn, in a region where there were no known stars, clouds, gas, or other objects capable of producing such radio emissions. Scientific teams thoroughly examined the recordings, analyzing every detail. And yet, nothing was found except for the mysterious sequence of numbers and letters. There were theories about a reflected signal from a comet, and about a random burst of energy from an unknown celestial body. But none of the hypotheses received 100% confirmation. Fans of conspiracy theories even suggested that the signal was deliberately sent to Earth by someone from the other side of the universe. To this day, the WOW case remains the most striking and mysterious discovery for those searching for extraterrestrial radio signals. Every year, scientists revisit this phenomenon, test new theories, and use increasingly advanced methods of analysis. However, none of them have fully convinced the scientific community. Against the backdrop of this mystery, another potential source of evidence for life beyond Earth seems far from coincidental: the rocks that have arrived on our planet from distant space. Let's move on to the stones that may possibly bear traces of life from other worlds. Stories about meteorites in which something suspiciously similar to bacteria was found begin with a discovery recorded back in the late 19th century, when unusual structures were found in the Orgueil meteorite in France. Microscopic examination revealed objects inside the stone that resembled fossilized bacteria. Even then, the scientific community debated, could a meteorite really have brought life to Earth? This hypothesis would later be called panspermia, and it would become one of the most discussed topics in astrobiology. In the 1990s, the meteorite ALH 84401, found in the Antarctic ice, attracted worldwide attention. It turned out to be very ancient. Its age was estimated at 4 billion years, and it fell to Earth about 13,000 years ago. Most importantly, this piece of Martian rock contained unusual microstructures that, in 1996, NASA declared could be possible fossils of ancient microbes. These structures looked like tiny worms, only 1/1000th of an inch long. For the first time, scientists spoke about this at an official level. Perhaps there really was life on Mars once, and its traces reached us in this rock. The discovery caused a storm in the scientific community. Over the following years, dozens of laboratories around the world studied the meteorite using the most advanced microscopes and chemical analyses. Nanoparticles of iron and unusual organic compounds were discovered, which could have been products of biological activity. However, skeptics quickly emerged as well. In their opinion, all these structures could have formed as a result of geological processes or terrestrial contamination. Nevertheless, Illinois H 84401 is still kept in a special NASA safe and regularly serves as the subject of new research. Another mysterious case is connected with the Murchison meteorite, which landed in Australia in 1960. This object weighed almost 130 pounds and turned out to be a real treasure trove of organic molecules. It contained amino acids, purines, and sugars, which can be the building blocks of life. In terms of organic content, Murchison surpassed all known rocks on Earth, and its age was over 4 billion years. This meant that the basic chemical components for life could have formed far beyond the Earth and arrived on our planet together with meteorites. To this day, science knows of dozens of space rocks in which traces of organic matter have been found, or even structures that do not rule out a biological origin. Research is ongoing. Scientists are developing new methods of analysis to make sure no detail is missed. Heated debates flare up around every discovered meteorite because confirmation of life existing beyond our planet would be one of the most significant discoveries in all of human history. But even if microbes in rocks from other planets remain a mystery for now, researchers have more and more reasons to search for life not only in remnants brought by space, but also on entirely new worlds whose conditions seem surprisingly similar to those on Earth. While meteorites under the microscope spark debates, another scientific front has opened up dozens of light years away from us. Since the early 1990s, astronomers have begun to discover so-called exoplanets, planets that orbit other stars. The first confirmed exoplanet was discovered around the pulsar PSR 1957 plus 1122, and by the late 1990s, a planet comparable in size to Jupiter was found orbiting a yellow dwarf similar to our Sunday. From that moment, a real race began. Telescopes all over the world started scanning the sky in search of Earth's twins. The main intrigue was whether it would be possible to find such planets where the temperature, atmospheric composition, and distance from the star would be suitable for the existence of liquid water. Scientists call these the habitable zones. The Kepler Space Telescope, launched in 2009, changed the entire picture. In just a few years of operation, it discovered over 3,000 new worlds, among which were Earth-sized planets located in the Goldilocks zone of their star systems. Findings like Kepler 442 billion reals and Kepler 452 billion reals attracted particular attention. These worlds are almost the same size as our planet and orbit their parent stars at distances where water could exist. Kepler 452 billion reals, for example, was nicknamed Earth's older sister because of its remarkable similarity. Even more intriguing was the TRAPPIST-1 triple planetary system discovered in 2016. In this system, all 7 planets are similar in size to Earth, and 3 of them are located right in the habitable zone. These discoveries sparked a wave of new research. After all, if even a small fraction of exoplanets resemble our world, it fundamentally changes the calculations for the probability of life existing in the universe. But the search for twins did not end there. In recent years, the James Webb Telescope has made it possible not only to discover new planets, but also, for the first time, to study the composition of their atmospheres. Spectra have already been obtained that show the presence of water vapor, methane, and even signs of carbon dioxide. On the planet K2218b, clouds have been detected, and its atmosphere contains carbon compounds. All these parameters are critically important for the search for biomarker molecules that may indicate the presence of life. So far, no unambiguous evidence of biological processes has been found on any exoplanet. However, the list of potential candidates grows every year. Every new Earth twin immediately becomes a target for radio telescopes and studies searching for unusual signals. Around some stars, mysterious dimmings have been detected that cannot be explained by a planet's orbit. and scientists are developing hypotheses from clouds of dust to entire gigantic structures, the so-called Dyson spheres. All of this keeps interest at its peak, as science is literally adding new worlds to the catalog every day. Back in the 90s, scientists knew of only one exoplanet, but today several thousand have been discovered, and almost every one of them has its own mysteries. But if the conditions on some of them are similar to those on Earth, a question arises. Can living organisms survive in much more extreme environments that exist on other planets? When scientists began to seriously study the possibility of life beyond Earth, they were particularly interested in the question, is there even a single living organism capable of surviving on other planets and moons where the conditions are far from those on Earth? To the surprise of many, the answer turned out to be much less obvious than previously thought. As early as the mid-20th century, biologists discovered so-called extremophiles on Earth microorganisms capable of surviving where temperatures reach hundreds of degrees Fahrenheit, pressure is hundreds of times higher than on Earth, and the acidity or salinity of the water would kill almost everything else known. For example, bacteria have been found 2 miles beneath Antarctic ice, in volcanic vents, in the hot springs of Yellowstone National Park, and even inside nuclear reactors where radiation levels are lethal to everything else. Spores of certain types of bacteria can withstand the vacuum of space, ultraviolet radiation, and extreme temperature fluctuations. In NASA experiments, bacillus spores were sent to the outer surfaces of satellites and the ISS, where they remained alive after months in space. Even fungi and algae survived exposure to open space, returning to Earth alive. These properties allow scientists to model how microorganisms could migrate between planets, for example, arriving on Earth on a meteorite, or conversely, traveling from Earth to Mars. But even on neighboring worlds, the conditions are not as hopeless for life as previously thought. In the hydrothermal vents on the ocean floor of Europa, Jupiter's moon, there may be an environment where terrestrial extremophiles could feel right at home. Analysis of the Martian surface shows that deep underground liquid water may persist at temperatures below 32 degrees Fahrenheit, an ideal niche for the existence of microbes similar to terrestrial anaerobes. Scientists have already created laboratory analogs of Martian conditions, selecting microbes that can survive in an atmosphere composed almost entirely of carbon dioxide, with weak sunlight and low pressure. On Saturn's moon Enceladus, where an ocean rages beneath an icy crust, the Cassini probe discovered methane and organic compounds in the water plumes, which suggests the possibility of processes similar to those occurring in Earth's deep-sea hydrothermal vents. Even on Venus, where the surface temperature is nearly 860 degrees Fahrenheit and the pressure exceeds Earth's by 90 times, conditions have been detected in the upper cloud layers, where microbes similar to Earth's acid-loving bacteria could potentially exist. Satellite missions have transmitted data about mysterious traces of sulfur dioxide and anomalies that some scientists have linked to possible microbial activity. All these discoveries and experiments of the past decade have significantly expanded our understanding of the possible limits of life. If it once seemed that life could only arise within a narrow range of temperatures and conditions, now scientists are seriously considering the hypothesis of life as we do not know it. Organisms that rely on chemical reactions impossible on Earth. Research continues. Automated probes are being sent to Mars, Europa, and Enceladus, and new biological experiments are already being planned for lunar and Martian stations. This leads to the next inevitable question. If life is so resilient and diverse, why have we still not encountered anyone in the vast universe? With the advent of the first telescopes, scientists were already amazed by the vast number of stars in the sky. But over the centuries, the scale has only grown. The Milky Way galaxy contains more than 100 billion stars, and scientists have already counted several thousand exoplanets. At first glance, life should be everywhere. However, not a single confirmed signal or trace of extraterrestrial intelligence has been found. This paradox was first clearly formulated in the mid-1950s by physicist Enrico Fermi, who posed a simple question: where is everybody? The search for a rational answer led to the hypothesis of the Great Filter, the idea that there is one or more nearly insurmountable obstacles on the path to intelligent life. Scientists suggest that filters may exist at various stages, from the origin of life itself, the emergence of multicellular organisms, to the development of technologies that allow signals to be transmitted across space. For example, it is possible that most planets remain lifeless due to unfavorable chemistry or catastrophes that destroy nascent ecosystems. Another scenario, even if life does emerge, the transition to complex organisms is extremely rare, since on Earth this required billions of years and many coincidences, such as the appearance of an oxygen-rich atmosphere or the extinction of the dinosaurs. There is yet another important hypothesis. Technological civilizations may disappear too quickly, without having time to leave noticeable traces in the universe. Radio signals are capable of surviving in space for tens of thousands of years. But if a civilization perishes just a couple of centuries after creating them, the chance of intercepting such signals is minimal. Catastrophes can take many forms: asteroids, nuclear wars, uncontrolled technologies, or simply the depletion of resources. Even today, despite powerful telescopes and satellites, we are only able to hear a very strong signal that is sent directly to us and on a specific frequency. Scientists are also actively discussing even rarer types of filters. Some suggest that advanced civilizations deliberately avoid making contact due to ethical principles, fear, or a desire not to interfere with the development of other worlds. The analysis of recent astronomical discoveries adds further arguments. We see thousands of exoplanets, but each one is slightly different from Earth in terms of conditions or size. Perhaps the exact combination of all the necessary factors is so rare that we simply haven't found the right way to search yet. At the same time, the vast distances in space are a real barrier in themselves. Even if signals are being sent from another galaxy, they would have to travel millions of light years, which means that all possible civilizations might simply not overlap in the time of their existence. Despite this, search projects continue to expand. Radio telescopes and satellites operate around the clock, databases grow every year, and more laboratories are searching for biomarkers on planets orbiting other stars. All of this shows that science does not give up and continues to seek explanations. But no matter how many filters separate us from meeting extraterrestrials, it is probability mathematics that provides unexpected answers to our questions. How great is our chance of actually seeing intelligent life one day? If we look at the problem from a mathematical perspective, it turns out that the chances of finding extraterrestrials are harder to estimate than they might seem at first glance. In the early 1960s, astronomer Frank Drake proposed his famous equations, which calculate the number of intelligent civilizations in our galaxy. The formula includes many variables: the number of stars with planets, the probability that such planets have conditions suitable for life, the fraction of planets where intelligence develops, and even the average lifespan of a technologically advanced civilization. Each parameter is based on real measurements or indirect assumptions. For example, according to the latest data, there is at least one planet for every star in the Milky Way. Of the several thousand known exoplanets, about 1 in 3 is located in the habitable zone of its star. From here, things get more complicated. It is unknown how often life actually appears on such planets, or whether it ever develops into complex forms. Science knows of only one technological civilization, Earth's sand. All estimates regarding the transition from microbes to intelligent beings are extremely tentative. But even with the most pessimistic estimates, the final number of civilizations in the galaxy sometimes exceeds 10, and sometimes comes out to just above 0. The range is enormous, and it depends on each parameter, which scientists continue to refine with new discoveries. Separately, the probability of contact via radio signals is assessed. Calculations show that if a civilization exists for at least several thousand years and sends out powerful signals, the chance of detecting them on Earth increases significantly. However, if the average lifespan of technological societies is short, the window of opportunity for contact may be only a few decades for each civilization. Even with billions of stars, the probability of two civilizations existing at the same time may be less than 1%. Modern astronomers analyze not only the sheer number of worlds, but also the characteristics of planets, the spectra of their atmospheres, and the presence of water, methane, and oxygen. They also have to take into account the impact of cosmic catastrophes, supernova explosions, and the stability of a planet's orbit. To refine all these parameters, scientists collect statistics from the latest telescopes, satellites, and research stations. Interestingly, some mathematicians use the so-called anthropic principle. If life could arise even once, then its emergence is possible elsewhere in the universe as well. In the 2000s, physicists combined elements of the Drake equation with a model of civilization growth to calculate how many signals we might potentially detect in the coming decades. The results so far are encouraging. The more telescopes we have and the longer we search, the higher the chance that first contact will eventually happen. There are no unambiguous signals yet, but the calculations confidently paint a picture where remarkable discoveries, random coincidences, and extremely rare catastrophes all play a role. Science does not promise quick results, but with each passing year, the Drake equation is filled with new precise data, and the likelihood of finding someone in space becomes just a bit more real. Signal hunters, meteorite researchers, and astronomers observing thousands of distant worlds continue to push humanity toward the main event of the future, a possible encounter with an intelligence that is watching us from another corner of the galaxy.